All right, guys, let's jump into question number 2. This one is really, really interesting as well. Really, really interesting. If we have more time, we're gonna continue with more exercises. All right, number 2. If you want to, guys, if you prefer it that way, you can give it a try. Try to do it at the same time as I try to do it, right? Okay, so we have two fair cubical dice. So since these are cube, we have six numbers, sorry, in each of the dice, right? So we have cubical dice, right? And we are rolling those two dice in a game. Now, the score is the greater of the two numbers. So for example, what is the score if I roll a 1 and a 3? What is the score, guys? Tell me. Tell me, open the mic or tell me in the chat.
3.
3.
Yes, it is 3. Because we are selecting the biggest, right? The greater of the two numbers. Another question, what happens if I roll these? 4 and 4.
4.
4.
4.
Well, 4, right? Here, in this case, they are not greater value. The 4 is not greater than 4, right? But since we have the same number, we're going to value that as the answer, right? Oh, look, we have it here. If the same number appears on both, then the score is that number. Cool. All right, let's continue. Find the probability that the score is at most 4. At most. All right, let's discuss this for a second. What is at most? At most makes a reference to having 1, 2, 3, or maximum 4. That is the idea here. At most means the score cannot be bigger than 4. All right. For this, we're going to make a sample space diagram. Hey. All right. Our diagram is going to begin always with the first quadrant on a Cartesian plane. So it's just like this, an L, right? Like you were doing a graph, a statistical graph, right? In both sides, in both axes, we're going to write down the possibilities. So since these are cubical dice, we're going to just write 1, 2, 3, 4, 5, and 6. Also in the other variable. 1, 2, 3, 4, 5, and 6. All right. Now we're going to write down every single dot in here. This will be easier for you if you have a grid paper, right? So use your notebooks. Use your notebooks for this. Grid paper are really, really useful for these diagrams. All right, it's going to take me a while. It's going to take me a while. La-da-da. La-da-da-da-da. La-da-da. La-da-da-da-da. Elevator music, guys. No, looks like a line. There. La-da-da. La-da-da-da-da. There we go. We have our points. Beautiful. How many combinations do we have? All we have to do is just count the combination, count the dots, right? If you prefer this way, you have a maximum of 6 here, a maximum of 6 there. You have 6 times 6, right? 36 combinations. You can also do it like that. This is a counting method known as the multiplication principle. You can do the multiplication principle. For those of you who saw class with me, you guys probably remember it, right? Probably. All right. So how many of these are successful? All right, let's try to answer our question like this. Let's go with question A. We are finding the probability that we have the score. I'm going to write it as S. Score is lower or equal than 4. That is the idea here. Look, at most means it cannot be bigger than 4. So like this, I am using proper notation. And this is a step you guys need to get familiar with if you want to get full marks in your quizzes or your examinations. All right? Use proper notation, guys. In this case, we can. S is lower or equal than 4. Remember, at most means the 4 is also a possibility, which is why we also value the equal. All right? Cool. Let's continue with this. So what is the probability here? Remember, We need to do success over total, right? For a total, we have 36 combinations. If you don't know how, just count the little dots. We have 1, 2, 3, 4, blah, 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 35, and 36. All right, 36 combinations. You can count them yourself. And on top, we're going to count the successes. But remember, the successful ones are the dots that are with this condition. So the ones that are lower or equal to 4. Let's see. This one is a successful one, right?
Mister, I have a question.
Yes, sir. Tell me.
For this exercise, we can just multiply 4 times 4. And
Can we? Look, if we do it, you're saying this. This is a good idea. Use the multiplication principle to see about the success, right? But if you do 4 times 4, what you're saying is that in each of the spaces, you have a maximum of 4 possibilities. And you will be correct. Right?
El
Because
Faru.
if we get a 5, then the maximum score is the biggest one, right? It's 5. So no, you cannot have a 5. Also with 6, cannot be a 5. Cannot be a 6 as well. I'm sorry, cannot be a 6. Because the maximum score will be a 6. And you don't want that. That happens for both this and this square as well. So yeah, that is a proper use of counting of the multiplication principle. Yes, sir.
okay, Mister.
Right. So we know already what is the answer here. 16, right? 4 times 4. Again, because you use the multiplication principle. Grau, beautiful, brother. Beautiful idea. Of course, this can be simplified, and we will do that in a second. Because before we do that, I want to still take a look at what are the successful ones. For the people who are not familiar with the multiplication principle, right? So this is a good answer. Why? Because this dot is the option of getting a 2 and getting a 1, which means the biggest is a 2. That is a good option. Let's continue. This and this, right? In fact, all of these are possibilities. Look at those. All of these are possibilities, 4 and 4. But the ones that are not highlighted are not good possibilities. If I highlight this one, for example, this one in here, that means I have a 5 and a 5. And the biggest one is 5. So no, not a good possibility. What if I also select a 4? I don't know. Let's select this 4 and a 6. So this dot in here. Well, in this case, in this possibility, the score will be 6. Remember, the score is the biggest of the two values, right? So not a good option. If we just count the highlighted ones, we have 16 as Grau proposed. Beautiful, brother. We can, of course, simplify this. If we do half, this will be 8 over 15 and 3, 18. Right? Again, we can simplify once more. This will be 4 over 9. Right? And I think this is the simplest form. So this is the answer. Grau. Beautiful, brother. Beautiful. All right, let's continue with question B. Look at these guys. In this case, we are going to do 945 trials. Okay, so we are not going to just throw the die once. No. We're going to throw both dice 945 times. The question is, find the expected frequency. So, the expected value. Of the event, the score is at least 4. At least. This changes everything, right? Look, let's begin. Let's break this little by little. So at least means that now we have to take into account 4, 5, and 6. That is the idea behind at least. The minimum value has to be 4. So we're looking for this probability, right? We're looking for the probability of the score being bigger or equal than 4. Again, in this case, I'm saying bigger or equal because we want at least 4. So the possible values are 4, 5, and 6, meaning we want the score to be bigger or equal than 4. All right. Look, I leave this space because of the question in this exercise. They're asking us to find the expected value. So we are not only asking for the probability. No. We want to go even further beyond. We want to find the expected value. Now, if you guys remember from the previous class, or I don't know, studied at home, you guys know that expected values are the probability of the individual event times the repetitions, right? So we need to find the probability, and after we are done with that, we're going to multiply by 945 repetitions, which are the trials. Okay, let's do that then. Beautiful. What is the expected value here? All right. The probability that the score is bigger or equal than 4. But we have it here, right? I am not even going to highlight it because, no, you know what? I have to erase some. Yeah, I have to erase some. Of course, this exercise can
27,
also be
profe.
done using the multiplication principle. So if any of you have the idea on how to do it, let me know.
Mister, can I say in Spanish?
Sure.
Acá no podemos usar la anterior, ¿no? La de, o sea, acá no podemos multiplicar 6 por 6. Pero pues yo lo que hice fue multiplicar 6 por 6, después 3 por 3 y restar la diferencia.
That's a good idea, brother. That is a good idea. That is a good process. That is a good process. I have another solution. Take a look at this. All right, number one.
Profe,
These, the ones that are highlighted, are, of course, the possibilities. Look, every single number in here will give you a score of 4 or 5 or 6, right? So these are the options. If we just count these, we have our success. Of course,
son
we can
27.
always see the total as 36, right? But how do we do this using the multiplication principle? Simple. We're going to do 2 spaces for each dice, right? This is dice 1, and this is dice 2. Now, let's think about the possibilities that we can have on each die. Well, in the first one, we can have a 5, a 6, or a 4, right? Which means we have 3 possibilities. Same on the second dice. We can have the number 6, the number 5, or the number 4. In other words, we have 3 possibilities. Possible combinations are 9. And this will give me a mistake. I don't know why.
Olibus, ya llegué.
Oh, hey, hi, Majo.
Profe,
Yes, sir.
pero es que digamos, el 4 también, digamos, porque si uno tira 2 veces el dado, le cae 1 y 4. Entonces esa sería otra probabilidad, ¿no?
You know what? Yes, you can do it like that as well. Yes, sir. So I think the option that Grau says was the easiest one. We have
Sí,
the maximum possibilities, right?
son 36.
And we are going to subtract from this one the other ones from 1 to 3, the ones that we don't want. Let me erase these. 3 and 3. 9, right? So 36 minus 9. Let me do this minus here in the middle.
27, profe, pero
We
es
have
que usted no me
27.
cree.
No, I do believe you. I said your answer was correct, but I thought I had another one. No, dude, I said your answer was correct. I just thought I had a different one. But no, turns out I don't have another one. Can I make it in a different way though? 1, 2, 3, 4, 5, 6. 1 and 1 cannot be. So 1 is not an option in the first one. 6 times. No, you know what? No, I can't. I think so. No. All right, 27. So these are the options, right? The ones that you count, or if you use the multiplication principle, you're going to have to do it as Grau did, right? All the combinations minus the bad ones. These 3 minus the bad ones. That is what we're doing. 36 minus 1, minus 9, sorry, a total of 27. All right, let's fill that in. our probability, and we're going to multiply that by the amount of trials, the repetitions, because again, we are finding an expected value. So this is going to be times the repetitions, so times 945. All right. What is our expected value then? Can anybody help me with this in the calculator, please? Anybody?
Profe,
Yes, sir.
es 45.
Ah, man, I hate it. I suck at this. Sorry. 45. Thank you.
Eso me dio 708.
708 point something, right?
75, sí, pero no estoy seguro.
0.75. All right. We can round this if we want to. This is an awful rounding sign. We can round this. They're beautiful. Round this.
Yo también me dio 715.
Who am I going to believe? 708 or 715? Look, this is the real repetitions, right? 945.
Ah, no, profe, me equivoqué. Paul tiene razón.
Okay. So we can try to round this to 709, right? So how many did you expect once you play this game? How many trials or how many combinations out of the 945 do you expect to be at least 4? Well, you expect them to be 700.78 or 709. All right, that's it. That's an expected value for you guys. Beautiful, huh? Man, I love this type of exercises. I love this type of exercises. These are really good ones. These are really good ones. All right, guys, we have 15 more minutes. So I could try to do the next one, number 3, but I am not going to be able to finish it in 15 minutes. That's just not going to happen. So we can begin with this one and, I don't know, maybe do the A and that's it, right? Or we can try to, I don't know, answer some questions about this, right? Do any of you have any question about these guys? Maybe one of you didn't get something? No? All of you good? Okay. Then we're going to have some fun of our own.
No, yo no, Gus, no, yo no.
Majo, we're going to do something different with you because you missed the entire class.
Okay,
Right? All right, we're going to do C.
está bien.
I am going to create a question
Okay.
and you guys are going to try to solve it. You guys are going to tell me the solution. All right? Look. Let's find the probability, a simple one. The probability that the score is at least 5. No, you know what? Not at least. That the score is bigger than 2, but not more than 5. There we go. This one. Let's do it like this. All right? Give it a try, guys. Tell me, how much is that probability? You know what? I'm going to help you with something. There we go. I just helped you.
25 sobre 36.
25? 36? Is that
No
correct?
estoy seguro, profe. No sé.
All right.
Creo.
Beautiful. Thank you, Paul. That's what you got. All right. Beautiful. Anybody else? Tell me, is that a good answer or not?
Profe, ¿es mayor de 5 igual a, o sea,
No,
mayor de
profe,
2
no
igual a 5?
entiendo.
Yeah, look, is bigger?
Ah,
Yeah,
no,
this is
entonces no, profe.
this is an S for
Embarré.
score, right? This is a score, right? So we want the score to be bigger or equal than 2, but also lower and equal to 5.
Medio 24, profe.
24? All right. Now, who was that?
Sí, da
Sebas?
24.
Okay.
Chiquito.
Sebas,
Yes.
24. There. Guys, anybody else trying this exercise?
Chiqui.
Tell me, is that a good answer or not?
Sí.
Yes.
Es una
Is
buena
not?
respuesta. Sí, sí la es.
All
No,
right.
sí, 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 profe.
Cool. Did you do it with the multiplication principle or did you do it using the sample space?
Profe, lo que hice fue, o sea, pues como el 1 y el 6 son los límites, pues simplemente los cuento cuántos puntos hay y los resto y ya.
Yes, sir. That is the multiplication principle for you. With a little bit of subtraction, yes, but that is the multiplication principle. So what Sebas did is as follows. He's gonna count the total possibilities, right? So he has 6 and 6. This is 36, right? But out of those 36, he's gonna cancel some. He's gonna cancel the ones that he doesn't want. So if the maximum score is 1, I don't think so. Yeah, so he's gonna cancel the 6, right? 1, 2, 3, 4, 5, and 6. And he's also gonna cancel another one. Did you forget about this one?
No, porque 6 y 6, 12 y menos 36, 24. Creo.
Yes. So these are the ones you're canceling, right? You're canceling these options and also these options, right? But also,
Y el 1,
you
1.
also need to cancel this one,
Ah, sí, me faltó
Sí.
la L.
right? So we need to cancel 12, we need to cancel 13, right? For a total of 23.
Profe, no se cancelan 13 porque en los 6 hay 11 en realidad, porque uno se comparte.
Ah, look
Ajá.
at that! All right. 24. All right. No, not with this color. Black ones.
Sí, porque el 6, 6 se comparte.
All
Exacto.
right. You guys
Uy, el Faru.
are really, really fast.
Gotcha.
Beautiful. 12 here. So 12 and 24. Beautiful. All right, pretty good. Now, every single one of the ones that I did not highlight, all of these, are the possibilities that are good, right? If we select any of these dots, the biggest value will be a 2, a 3, a 4, or a 5. Beautiful. We can just count these little dots in here. We can just count them or do the multiplication principle as these guys are doing. As usual, I like to do the multiplication principle as well, as usual. But the sample space diagram is a really, really, really good option for those of you who don't like to multiply, right? All right, let's try to do another one. Can we do a conditional probability here? Can we do a conditional one or not? So yes, we can. Yes, we can. An absolutely simple one. La-da-da, la-da-da-da-da. Let me erase all of these. All right, let's do question D. Try to find these guys. Find the probability that the score is exactly, no, find the probability that the score is lower than 3, lower or equal than 3. Given that, do you guys remember this little line? Given that the second die is at 2. All right. All right. Try to find this probability, guys. Try to find this probability. This is a conditional probability, right? We need to make sure we take into the account the condition. And this diagram over here is absolutely beautiful for this probability.
¿Cómo así, profe? No entendí la pregunta. O sea, dice, no entendí.
Okay, again, I think I explained this in the past, right? Whenever we have something like this, something and then this line and then something, the second option, the second event, this one, the one after the line, is the one we know as the condition. The condition is something that has to happen before I can take into account, the first condition or the first event, right? So for example, in this one, I need to take into account the condition. The second die has to be 2. Let's say this is the first die. Let me write that down here. This is the first, and this is the second, right? The second die has to be a number 2, meaning these are all the possibilities. That's it. We don't have no more possibilities, right? Because that is our condition. We have to make sure our example take this condition into account. That is a probability, a conditional probability, a probability that has a condition in it. Again, whenever you find this expression, whatever is after the line is the condition and has to happen first. Because again, it is a condition. That is the line I was talking about. All right. So let's try to answer this question, guys. What is the probability that the score is 3 if we know the second die has to be a number 2?
Profe, 8 sobre 36.
Let's see it. All right. 8 out of 36. Is that correct? Let's see. Lower than 3. Not really. Let's see. I'm going to tell you why. Simply because the total has to change. I don't know about the one on top. I don't know the success. I don't know about that one. But the one down has to change. Why? Because of the condition. The condition makes it so that now we don't have 36 possibilities. Now we don't have 36 possibilities. No. We have lower possibilities because remember, the condition has to happen first. So out of the 36, out of the 1, 2, 3, 4, 5, and 6 possibilities that we have, because these are the only ones that take this event into condition. We're not gonna think about these ones, for example. These are not good options because they don't take the condition into account. How about these ones? For this one, the second die is number 5. And we want the second die to be number 2. So these ones are not a good condition. That is the idea behind conditional probability. So our total here changes. And it is now 1, 2, 3, 4, 5, 6. Now, how many of those 6 are successful? So how many of those 6 make it so that the score is less or equal than 3?
3.
Así, 3.
Ah, listo, listo.
Chiqui.
Let's think about
Qué
this one.
pena, Paul.
Let's think about this one. What is the score here? 2 and 1. What is the score there?
Less than 3. And the second die.
That's less than 3, right? That is 2. That's less than 3. So this one is successful. How about this one?
Less than 3.
Right? So that one is successful as well, right? How about this one?
Equal to 3.
Equal to 3, which is also successful, right? How about this one over here?
More than 3.
Ah, that one is more than 3. We don't want that one. Also the one next and the one next. Meaning, the only 3 that are successful are these ones in circle. 3 over 6. Which can be simplified as 1/2. There is a 50% possibility that if you get a 2 in the second dice, you are going to have a score lower or equal than 3. Man, conditional probability. Conditional probability. Can we do another one? Let's try it. Let's
Profe,
try it again.
puntitos por participar.
Yeah, sure.
Eso, eso.
I'm not saying. Look, I'm not being sarcastic. Yeah, sure. I will give you points. Absolutely. I'm not being sarcastic. All right. You will have those points. All right. B. B of another conditional probability. You know, another conditional probability. Let's make this score bigger than 3. Bigger than 3. All right. No. Bigger than 4 in this case. Bigger than 4. All right. But we want it's gonna take a long time and we don't have that much time. We want the first die to be a 1, a 3, or a 5. There we go. There we go. All right, now we are talking. Let's try to find this probability, guys. Let's try to find this probability. Let me erase all of this here. Again, everything after the line is the condition, and that condition has to happen first. So that condition is going to affect our total. That is what we need to think first then. What is the condition? The first die has to be a 3, a 1, or a 5. By the way, I am explaining this, but if you get the answer, just let me know, all right? Just let me know. So these are possible options, right? These values take the condition into account, right? Also these ones. These ones take the condition into account, right? And also these ones. Beautiful. All right. That is the condition, meaning we have a total, right? The total are just these 3. Times 6, right? 1, 2, 3, 4, 5, 6. Beautiful. So we have 18 possibilities. That is the total. Those are the ones that take into account our condition. Now, out of those 18, how many of those make it so that this score is more than 4? Be careful about this. I'm saying more. I am not saying more or equal. I'm saying bigger than. I'm not saying bigger than or equal.
6.
6? All right, let's see. Let's see. So this is a good possibility. This is a good possibility. This one over here is not a good possibility. The score will be 4, right? And also the ones down will be lower than 4. So nah, right? This is a good possibility, good one, and good one. Notice how I am only taking into account the ones that are on the condition. Look, this is a good possibility. The score here is bigger than 4. Also this, bigger than 4. But those don't take the condition into account. So I don't want those. In other words, this will be the probability, 6 over 18. But we can simplify this. We can simplify this. This will be a half and half, so 3 over 9. We can simplify by 3. So 1 over 3. Yes, Santi. I think it was Santi, right? Or Paul? I don't know who was.
Me extraña, profe. El Paul.
1/3. Beautiful. 1/3. You got it right, brother. You got it right. It was 6. Congratulations. All right. This is how you use a sample space diagram properly. And look at how many beautiful, beautiful questions we can think about just by taking a look at this diagram. All right, guys. All right, that's going to do it for today. I'm going to stop the video here, and we're going to jump into today's quiz. Stop the recording.